Okay, our last lesson, lesson 5, cross products, sometimes called vector multiplication, but as I think I've mentioned, I don't like that. So it is used, however, please keep in mind, you cannot multiply two vectors together. You can take a dot product, which we have already learned, or you will now be able to take a cross product, or in a couple of minutes. So if we look at the basic mathematical definition, notice we again have the 3 equals sign. So I'll erase that, but I don't like it. We have the 3 equal signs, so it's an equality by definition. So this is by definition. So we don't worry about a theoretical proof for y. When we take A cross B, and again, get used to not saying A multiplied by B, this is cross. We write the word cross, and we use the word cross when we speak of what we're doing with the vectors, A cross B. We take the magnitude of vector A, which is positive, the magnitude of vector B, which is a positive, because again, the least amount of a vector you can have is 0, after which you have nothing. We are again taking the sine of the angle between the two vectors, not around them. So we are again drawing them from a common origin, just like we did with dot product, but now we are doing sine instead of cosine. So there are two major differences in terms of dot and cross product. Cross product uses sine, and I think most importantly, dot or cross product is a vector answer. So this is really important. Just like we said it was really, really important not to have a vector answer. With your dot product, it is really important that you do have a vector answer with your cross product. So let me clean this up a little bit so my page is a little less messy. I'll leave the rest. Okay, so, well, almost. So what we are going to do, and we're going to look at this by example, is pretty much establish the vectors the same way. We're going to draw them from a common origin. So I have my common origin here. We draw vector A, vector B, no matter how they're given to us in the problem, no matter what angles are given to us in the problem, we draw them from a common origin, and we find the angle between them. Okay? And we take A cross B. So we have the magnitude of vector A. In this case, we were given a 7. We have the magnitude of vector B, which is 3. We're taking the sine of 35 degrees, and we get our answer 12.05. Okay? So that will always be positive. So when we do AB sine, we will always get a positive answer when we do that multiplication. So the question now is this n hat. Like, how do I get the direction of the vector? And by the way, this is important. We get a vector. So A cross B generates, A cross B generates vector C. So we have vector, trouble writing, vector C. So when we take A cross B, we get vector C. Vector C has a magnitude of 12.05. Now, how do I know the direction was positive z hat? Well, this is called the right-hand rule. And the best way for me to explain this to you, especially on a video where you can't see my hands, is to describe to you what I'm doing and have you mimic it right as I do it. So the first thing I am doing is I am going to take my right hand and I'm just going to hold it to the page like I'm going to karate chop the page. So right hand is important, right hand rule. So straighten your fingers, put your thumb down like you're going to karate chop the page. You are then going to, so your pinky would be impacting the page. You are then going to rotate your hand, and I know this might be a little uncomfortable, so that your fingers and your pinky are pointing in the direction of vector A. Your hand is still in that karate chop position, perpendicular to the page. You are then going to curl your fingers to make a fist. You will always be curling your fingers to make a fist in the direction of vector B based on the angle that you used in your calculation, 35 degrees. So I'm going to curl my fingers towards B. To make a fist, I'm going to stick my thumb up. Your thumb is the answer. That's the n hat. So in that case, my thumb is now sticking out of the page. I hope yours is as well. So that is the positive z hat that we are looking at. And we will do this in class as well. All right, so let's take a look at another example here. So if you were given the vector A is 10 meters, and the vector B is 3, and you're told that the vector A is 20 degrees from the x-axis, and the vector B is 45 from the negative x-axis, so they're the angles you're given in the problem. You're given the magnitudes are 10 and 3, and you're asked to take the cross product. So we want to get, what does that vector C look like from our cross product? Well, we do AB sine theta, so we would do 3 times 10 times sine of the angle between the vectors. Now remember, for the angle between the vectors, do not just use the angles that they give in the problems. Don't do it. You actually have to draw them from a common origin and make sure you calculate the proper angle between them. So in this case, we have 180 degrees total that we're looking at. 20 and 45 is 65. So we have 115 degrees in between, so we have to take sine of 115 degrees. When we do that, we should get, I hope we get, 27.19. So you can check to make sure that's correct. So the 27.19 is the magnitude of vector C. That's the magnitude of our cross product answer. Now the positive z hat, same deal. It's that karate chopping right hand rule. We put our right hand down, karate chopping the page, rotate our right hand. It's a little uncomfortable to have our pinky point in the direction of vector A, curl our fist in the direction of vector B, and stick our thumb out. So positive z hat. Notice, had we been told to do B cross A, we would get the same numerical answer. The 27.19 would be the same. So A cross B gives positive z hat 27.9. B cross A will still give us the 27.19, but now we have to, what I call reverse karate chop. My thumb is going to impact the page. So I'm still in that karate chop position, but I have to rotate my hand upside down to have my thumb impacting the page. Again, it's a little bit uncomfortable, but now I can make my fist in the direction of vector A, and now your thumb should be pointing downward in the negative z hat direction. So when we take cross product, A cross B, we always generate a vector C. That vector C will always be perpendicular to the plane that vector A and B make when they're drawn from a common origin. So mostly for class and solving problems, we'll be working within the plane of the page. It's convenient. You have a page, it's a plane, you draw the vectors in the plane of the page. For that case, if the vectors are drawn in the plane of the page, there's only one of two possibilities for your vector answer, either positive z hat or negative z hat. So your thumb will either be into the page or out of the page. When you take cross product, you get a vector answer. You have to have the vector symbol as part of your answer. You do need to remember that you're using sine versus cosine, and the positive or negative will always be associated with the z hats, not with the angle, sine of the angle between 180, because sine is always positive between 0 and 180. Okay, and in our next lesson, our final lesson, we are going to look at some numerical examples.